Transforming functions, reflections. There are two kinds of reflections that I'm going to discuss today. The first one is the reflections of the type y equals minus f of x. So, as in all those situations of transformations that we encountered before, let us imagine a function f y equals f of x in general terms, and a new function g, which is defined by the formula y equals minus f of x in accordance with this here. Okay, so we have two different functions. Here in my picture, this green function is the function f, and point A is the point on this graph of the function. So point A has coordinates a, which the first one is the x, this number here, and the other one is f of x. So these two are define the position of point or location of point A in the plane. And now we need to do the same for this point B on the graph of the function g. So this is the function g, the new function that we want to construct. Now to do it, we have to start with x. Now find the value f of x, so these two things define the point A, and then use this value of f of x and multiply it by minus 1. So we multiply it by -1, or take the opposite number, so it's minus f of x, and use this number as the y coordinate of the point on the g curve. So this point B on the new function, on the graph of the new function, is going to have the same coordinate x, but minus f of x as its vertical coordinate. Now you can see yourself what happens here. If the coordinate f of x was positive and in some distance from the horizontal axis, the coordinate of the point B is then going to be negative at the same distance from the horizontal axis, but not above, but below. If the point A had the negative y coordinate, then the y coordinate of the point B would be positive. These 2 points are reflected in x-axis. So A is the reflection of B and B is the reflection of A in the x-axis. The x-axis here works like a mirror. Okay, so now let us see this in motion. Here is the model in GeoGebra. Now I can move the value of x, change it, and you see that as I move x, the point on the horizontal x-axis, also the point A moves on the original graph, on the graph of the original curve, original function, and so also does the point B move in accordance to this. And the distance between the axis and point A and axis and point B is always the same, so therefore this is really a reflection. This time here the y coordinate of A is positive, the y coordinate of B is negative, but if we move somewhere here and perhaps make it a little bit larger so that we can see the detail, in this region the y coordinate of the point A is negative, and thus the point A is below the x-axis, and the y coordinate of the point B is positive, and thus point B is above the axis. There are 2 points in which this A and B will coincide, this point and this point here at 1. These are the points in which the original function intersects the x-axis. So in those points the original function and the new function have to have the same y value. Okay, so this is the conclusion for this kind of reflections. For y equals minus f of x, we reflect y equals f of x in the x-axis. So we obtain the new graph by reflecting the original graph in x-axis. The points in which the original graph intersects, the x-axis remain at the same place, all the other points are reflected. Okay, now let's go to look at the second reflection of the kind y equals f of minus x. So this has to do with another reflection in the y or in vertical axis. Let us explain. So again, function f is this green function, and it is given by the following assignment. You assign the value y to the value of x using some arbitrary formula. So y is f of x. F is some formula, whatever you can do with x, calculate it like this. Now, if you consider function g, which is this red function here, defined in the following way: y equals f of minus x, you can draw also its graph. So how to construct point B on the graph of the red function? What we need to do is to start with x. Okay, so we start with the value of x, and then we have to find minus x. Okay, so when this is x, then minus x is here. This point is the reflection of this point in vertical axis. Okay, so this and this are reflections of each other. Now, having the minus x value, what we need to do then is to calculate f of minus x. So f of minus x is actually here, and thus this point A on the graph of the green function has the coordinates of minus x and f of minus x. Okay, so these are the coordinates of the point A on the graph of the green function. Now, having the y coordinate of point A, we use it to define the y coordinate of point B, because this is nothing else than g of x according to this, or you can say according to this. Okay, so g of x is f of minus x. So this point B here has the coordinates of x and f of negative or minus x, like this. So since the y coordinates of A and B are the same, and since the x coordinates are x and minus x, then we can say that point B is the reflection of point A in the vertical axis y. So this is the vertical y-axis. Now, as we move x, the point B will move, and also point A will move, and then the entire red graph is going to be the reflection of the entire green graph. To see it, let us look at the model. Let me open it first. So we are looking for f of minus x. Here it is. Edit. Okay, don't save that. Let me enlarge it. So here it is. I can now change the position of x, increase it. It moves point B to the right, or decrease it. It moves B to the left. And always, as B moves, also A moves. So these motions are interconnected. And you always see that B is the reflection of A in vertical axis. And so also the green curve is the reflection of the red one, and vice versa. The red one is the reflection of the green. So this is it. This is the model, and now we can conclude it in this sentence. For y equals f of negative x, we reflect y equals f of x in the y-axis. Okay, so this concludes the video. Now let's do the problem set.